Thank you very much. Yes, my name is Meredydd. I'm one of the founders of Anvil, and today I'm going to be talking about a better way of building web applications, which is a bit of a bold claim. But let's just stop for a moment and take a look at how you'd build web applications today. Anyone who's in view of the camera, how many people actually build web applications? Give me a big wave. Yep, okay, yes, there's a whole bunch of people suffering under this one, in which case you guys will know what this is about. If you're building a web application using the standard set of tools that we have today, your data is going to be in so many different shapes from over the course of your application. It is going to start out probably as rows in a database table, accessed by SQL. You are then going to have to transform that data into objects on your server, probably Python, given this audience, but those objects are going to have their own methods and their own attributes to access them. But then we're going to immediately turn around and represent those objects as JSON, accessed over HTTP with this really weirdly limited set of verbs like get, post, put, delete. But on the other end of that HTTP connection is a browser that's turning those back into objects, this time in JavaScript with their own set of methods and their own set of attributes. We're then going to render those into the HTML DOM, and we're going to have to then apply one more transformation with CSS to turn that into the pixels the user sees. And I mean, apart from being objectively nuts, every layer of this transformation is tedious and repetitive, and that invites just the wrong sort of magic. What do I mean by the wrong sort of magic? Well, I'm going to take a totally unfair pot shot at SQL Alchemy. So people in here, the web folks, I'm imagining will be roughly familiar with SQL Alchemy. Again, give me a wave, rough level of familiarity. Yeah, okay, I see some movement. So SQL Alchemy is actually, it's a library for representing SQL database rows as Python objects. And it's a totally unfair pot shot because it's actually pretty great. I mean, it lets you write expressions like this. Query for books, filter where the price is less than 20. That's nice. But the process of getting from this Python expression to SQL that you can run against a database is black magic. We're talking meta classes. We're talking standard Python operators overloaded to do something completely different to what they normally do. It's cool, and it's okay if you do it once. But if you have this level of magic at every layer in this stack, you are in for a bad day. But of course, that's exactly what we do. We have ORMs like SQL Alchemy to turn database rows into objects. We have REST frameworks to help us express those objects as HTTP endpoints. We have JavaScript frameworks on the other end like Angular's resources, turning those HTTP requests back into JavaScript objects. We have templating engines that are representing those objects in HTML, and we have CSS frameworks to help us put the right thing onto the screen. And God help us, but every one of these frameworks is like this, right? It's abusing the semantics of one layer to represent a different layer, and to use any of them at an expert level, you need to understand what's going on above and below it. It's hard work. We're a Python group. Let's stack that up against the Zen of Python. Simple is better than complex. I mean, just count the programming languages. I count 5. You might count more. If the implementation is hard to explain, it's a bad idea. Again, who really understands how Angular or React work inside? Because I don't. I mean, I have a rough idea, but how that implementation works, ugh. Here's a famous one. There should be one, and preferably only one, obvious way to do it. Hoo boy! So, okay, the web is pretty un-Pythonic in ways that make it hard to program. So how could we do it better? Well, this is our approach. We take this huge number of representations and all these translation frameworks, and we replace them all with a single representation in Python. So we are putting Python at every layer in this stack. So how we do it is we actually have a visual UI builder instead of having to muck with code and then effectively recompile in order to see every UI change. We write Python code even for the code that runs in the browser. And what that means is that if you're running Python in the browser, then those user interface elements you've been creating can just be Python objects and can be manipulated directly rather than through, indirect ping pong through templating libraries. Of course, it's Python on the server, but if it's Python on the client and Python on the server, we no longer have to mash all of our objects into JSON and using this weird set of verbs. No, we can just make function calls. And we even have a Python native database, optional, of course, which represents its tables and rows as Python objects, which means that we're all in one language from top to bottom of the stack, and we can pass objects around from top to bottom of the stack freely, which eliminates all that effort that those pink boxes were trying to help us overcome. It's gone because this is just one language and one representation, and you can bring a database row all the way from the database to the visual UI builder without having to change its representation. All right, that's enough talk. Let's see what that looks like in practice. So if you guys have, if the screen share has followed me, you should be looking at the Anvil homepage at anvil.works. And I've just clicked to log in. I am going to create a new app and pick a theme. Okay, so this is the Anvil editor. This here is a web page, and this is a toolbox of things I can put onto that page. So I want to put a title on my page, so I'm going to grab a label and I'm going to drop it in the up in the title bar. I'm then going to go scroll down, edit the properties. I can take the text of that label and change it to say hello world. And that's how I put a title on my page. Okay, let's do something a bit more fun. I'm going to build like an interactive hello world where it asks you your name and then just greets you by name. So I'm going to put a card on the page. I'm going to put a label in here that's going to prompt the user to enter their name. I'm going to put a text box in here so they can answer that question. I'm going to call this name box. Everything in Anvil has a variable name. All these components have names so we can access them from code. I'm going to put a button here for them to click when they're done. And we can go and make that a little bit more prominent. And finally, we want to display a message. So we're going to put a label here for that message to be displayed on. We're going to call it message label. And we can edit some more properties. We can make it centered and we can make the font size big and so on. So we've just built a web page. And that's an awful lot faster than it could have been done with HTML and CSS. But the really cool thing here is that it's all backed by Python. So if I double click this button, I am now editing the Python code that runs when that button gets clicked. And all those things you saw me drag and drop onto the page are available as variables in my Python code. So if I want to change the text on that text property of that message label based on the text that's in the name box, I go self.messagelabel.text as hello self.namebox.text. And that's it. They're just Python objects. That was just a Python expression. Let's give this app a name and run it. Okay, so we've just built a working interactive Hello World app, and that was pretty fast. Let's put it on the internet. So this is its URL. This is a private URL. It's like one of those Google Docs sharing links. If you have the URL, you can access it. If you don't, you can't. Let's make it public. Let's say hello IndyPy.anvil.app. Okay, so any of you could get your phones out right now and go to hello-indypy.anvil.app, and you will encounter this app. So we've just built and published a web app in a very, very short period of time. Now, of course, everything we've done so far has actually been in the browser. Even this Python code gets compiled to JavaScript and runs in your web browser. And that's great for this demo, but in practice, any sizable application is going to require some sort of server-side code as well. And for that, we use server modules. So a server module is a Python module that runs on the server, unsurprisingly. Ordinary Python module, and this is an ordinary Python function. So far, so good. But what I can then do is I can say, actually, I should be able to call this function on the server from the client. So I just tag this as anvil.server.callable to say this is a function on the server that can be invoked from the client. So if we go back to the browser, this is the code that runs when the button gets clicked. As well as updating the UI, I can also go anvil.server.call and call this say hello function. It wants a name parameter, so we will we'll pass in the text from the name box. And again, that's it. So now we can see we've got some log output. So we can now see that that print statement has just run on the server. So we're now driving this server-side code from the Python UI we've just created. So this is quite a big deal, because sure, this stuff's inevitably going to be limited, right? We can't compile everything into JavaScript. It doesn't make sense to open a file in a browser. But this is real Python, okay? This is the restricted sandbox, but okay, now this is real Python 3.7. And you can do what you want. If you have a database, you can import the library to connect to it and go. You want to draw a graph with matplotlib, you can import matplotlib and go. You want to use TensorFlow, we've got that installed. In practice, though, people who aren't just making a simple app wrapping a Python library, the first question they ask is, okay, so how do I, what's the easiest way to set up a database? So we actually have a database built into Anvil. It's called the Data Tables Service. It's backed by Postgres, so it's a real thing. You could put terabytes into here if you wanted to. We're not going to be that adventurous. We are just going to make a table to store all the names that get entered into this Hello World app. So we're going to want a column for each name, that's just text, and then a date and time column for when it was they signed up. And that's it. We've built our database. Again, I haven't had to set up any servers. I haven't had to drop to a SQL command line. It's just there. This table is called apptables.visitors. It's accessible from our code just like those UI components were. So if I drop back to our server module, as well as printing that thing to the logs, I can take apptables.visitors and I can add a row to it. I can fill out the name column with this name that's been passed into our function. I can fill out the when column with datetime.now, and you have 10 seconds to call out the obvious beginner's mistake I just made. I forgot to import the datetime module, which means that when I try to do this, of course, it's going to explode. Oops, name datetime's not defined. But we have a stack trace in the logs. We can go right to the line of code where that occurred. We can even go up the stack trace and find the line of code in the browser where that was called from, because this is just a Python function call. This is the kind of thing you ought to be able to do, and it's silly that you can't on the modern web. Anyway, let's go fix that bug. And run it again. Okay, so if we go back to the data tables, sure enough, we have just added 3 records to that data table. So we have just built and published a database-backed web application. And let me remind you, that's all at a URL, hello-indypy.anvil.app that any of you could be accessing right now. We have built and published a database-backed web application in a very, very short amount of time. I'm going to show you one more thing. Because we've just talked about adding rows to this database. I'm just going to show you how simple it is to display rows as well. So what we're going to do is we're going to want to fetch these rows. So we'll want a server function that does that. So we're going to make a server function, get visitors. It's just not going to take any arguments. It's just going to return at tables.visitors.search. If we don't provide any criteria, it will just return an iterable object that goes over all rows in that table. Okay, and now let's go to the form. So this is the web page. Let's put some UI in here. That was the wrong thing. I wanted a card. That's better. I'm going to put a data grid in here. And I'm going to put in 2 columns. It's going to be name, which is the name, title name, the key is name, and when signed up. And the key for that is going to be the when column. And we can tweak these and shrink this column down a bit. Okay, so we've just built a data grid. In this data grid is something called a repeating panel. This is a component that has an items property, and you set this items property to anything that can be iterated over, anything iterable, and it takes this template and repeats it for every element in that list. So if we take the repeating panel and we set its items to that iterable thing we just got, so here, remember, we're in the dunder_init function for the page, so this will run on startup. We can take the repeating panel and set its items to the return value of the getVisitors function. And that is, oh, hello. And that is how you pull these things. Okay, that's scrolling a bit. Let's go back and let's paginate this list. So let's go with maximum rows per page of 10, so it stays on my demo. There we go. So you can see we've just we have displayed data from this database on a paginated in a table, again with very little code. Of course, it's kind of a crude default display. It's just taking a stir of everything, which is fine for those names, but the stir of a date time is kind of ugly. So let's go fix that. So what we want to do is we want to edit this template. And instead of the default thing for the when column, we're going to put a label in that column. And then we're going to set up a data binding. So this is going to set the text property to this Python expression. Now, self.item is this element in the list that's been given to the repeating panel. So in this case, it's the database row. So we can use dictionary style syntax to pull out the when column, which is, of course, a date time, which means that we can just call stirf time on it. Okay, a little bit of Python, and now all those dates are nicely formatted. So we've just built, we've done database access, we've done database retrieval, and you can see how we blend the drag and drop designer and Python expressions to make a very powerful programming system. I could go on all day with demos, so I shall restrain myself and get on to some of the more nitty-gritty stuff, because I'd like to talk a little bit about how this works under the hood. So let's start with compiling Python to JavaScript, right? You've noticed that we were writing all our code in Python there, including the stuff that was running in the web browser. Obviously, if something's running in the web browser, it's going to have to be JavaScript at some point, and we need to turn A into B. Thankfully, there's this great open source Python to JavaScript compiler called Sculpt. And you can give it a Python expression, and it will produce some JavaScript code that does the equivalent. You give it a Python function, and it will produce some really, really nasty JavaScript code, but it will do what that Python function does. So this is great. But the problem is that JavaScript, in its infinite wisdom, is a strictly non-blocking language. If you do anything that is going to take some time and get back to you later, you're going to need a callback. For example, here's some code that you might write in Python. Right, get a row from a database, do some computation on it. Here's what that sort of flow looks like in JavaScript. I count 3 nested callbacks. And lest you think I am exaggerating this, this was copied and pasted from the first page of the Postgres JavaScript API documentation. I'm sure you can do promises with this, but it's still, you're going to be writing that many that many anonymous functions. But we have a Python to JavaScript compiler. So what if we could transform this into this automatically? So we git clone and get exploring. It turns out that the Sculpt compiler is a fairly standard compiler architecture based, unsurprisingly, on CPython. So what you give it some Python code, it then tokenizes that into atoms that are relevant for Python. By the way, all these JavaScript file names are the file names in the Sculpt source tree if you want to follow along from the slides. And then it turns these tokens into an abstract syntax tree that represents operations that we would regard as, we're familiar with in Python. So, assignments, function calls, variable dereferences, constants, and so on. And then there is a compiler that walks over this tree and spits out JavaScript. So it's obviously this compiler that we're going to have to modify to generate non-blocking code. So what do we do? Well, the compiler is outputting a JavaScript function for each Python function, so we can't get away from the fact that that function has to return, it cannot block. So what we do instead is we make a new JavaScript class, we call it a suspension, and if a compiled function returns an object of type suspension, that means it's returning, but it's saying, I'm returning, I'm not really done yet, I'm just blocked. And in that suspension, it will wrap up like all its intermediate states. So, all its local variables, all its temporaries, where it is within the function and that kind of thing. So the actual compilation will compile a function call to something like this. So every time it makes a function call, it will check whether that function has returned a suspension. If it has returned a suspension, we save a suspension of our current function call. So save all our locals, save all our temporaries, and also save, obviously, the inner suspension and return that. So we will return a suspension and we'll block right the way up the chain. So if you write something like this, so you've got a function that's going to be called from JavaScript and it's doing some blocking operation, you'll get some, it'll hit the database. That will block, that will produce a suspension. The get function is going to work out, it's got a suspension rather than a result, so it will save its own locals and temporaries and where it is in the function and produce a suspension that wraps that. And button one click will work out that get has returned a suspension rather than a result, so it will also save all its locals, save all its temporaries, save where it is in the function, return a suspension to JavaScript, which will happily sit on it. And then a few milliseconds later, when the database comes back, we can do the whole process in reverse. We can resume that suspension, which is a way of calling the button one click function, but with flags to say, actually, you're not being called, you're just being resumed with this suspension. At which point it will it will restore all its locals, restore all its temporaries, jump to the right point of the function, and resume its inner suspension, restore, jump, resume inner suspension. The database will go, oh, well, I have data now, and just return normally, and we're back to normal execution. So that is how we compile blocking Python to non-blocking JavaScript to make Anvil easier to use. If you want to check out more details, sculpt.org, I'm one of the maintainers. We're always looking for more contributors. Please do come join us. Okay, let's talk about something else you saw in that demo. The way that we're doing function calls from the client to server. So this is, instead of mashing everything through JSON and REST. So the function calls look something like this syntactically. It goes anvil.server.call, and then we name something that's on the server. And then we pass, it's a Python function call, so we can pass positional arguments, we can pass keyword arguments, and we can have return values. So far, so good. The implementation, it's a remote procedure call, it's piped over WebSockets, and all the arguments and return values are, well, the easy ones are encoded as JSON, and that's okay for all the things that can be encoded as JSON, like the example you see here. But of course, there is also non-JSONable data. Specifically, you've seen me passing database rows and search queries around like they were nothing. So this is obviously something we wanted to do because we wanted, again, there's a database. These rows are just objects that you can just get out in your server code. You can freely return those, pass them to and from client code. And when they arrive in client code, those rows are objects. They're not dictionaries, even though they have a get item method, so you can access them this way. You can update them, you can delete them, you can query their IDs. They are real objects, and we should be able to treat them as such. So what we've created is a type of object. We call it a live object. So that's an object that represents a server-side resource. Any client-side state is just caching for performance, and it should be secure. Specifically, possession is permission for these things. And what that means is just because a server function has returned a database row to you doesn't mean that you as on the client can access any database row in the system. That would be very dangerous. Instead, what we want is to enforce that you could only access the stuff that server code has chosen to return to you. So the way we do that is we represent every live object as an immutable ID. So say this table, this row. A set of methods, so update, delete, get item, set item, and a set of permissions. In this case, read-only. It's flagged as read-only. And then we hash all of those things, and as the server sends them to the client, it applies a signature that is specific to that client's session. And when the client wants to pass that live object back to a server function or call a method on that live object, it has to supply all of these things, including the signature, at which point the server can verify the signature and say, yes, they really do have read-only permissions on table 492 row 17, because they have a signature that's valid for this session, so I must have given it to them. This is also known as a capability architecture. So this is how it looks in practice. Again, as a general match to the intuition of passing things around, if you return something, that just means the caller can read it. So here's an example of some code where it's a server function that is passed in a name. It checks whether there's a logged in user. And if there is a logged in user, and only if there's a logged in user, it will go to the database, search for a row, and then return it. And that will give the client the ability to do read-only things. So, for example, here we're getting that object and we are pulling a column value out. Of course, we can do better than this. We don't have to be read-only permissions. We can actually give the client write permissions to a particular row or subset of rows. So here's an example that if the user is logged in, it takes the people table and then it makes a client writable version of that table, and then it searches that. And so the row that gets yielded here will be a writable row, which means that we can call set item on it as well as get item. And all of a sudden now, in your client code, you can do your data manipulation. You can update your database from your button click handler if you want to, which means that, again, you don't have to do this thing of for every possible operation, you need to set up the server code that runs it, the objects to do that, the HTTP endpoint with appropriate authentication, the rest stuff, and then a mechanism of the client to call all that. No, you just have an object in the client and you've been given it with the appropriate permissions, so you just call a method on it. Done. We can get fancier than that. We can have views. So just to clarify here, tables are themselves live objects. You can return a whole table. This could be, again, useful if the client doesn't have read permission on a table, but the server says, actually, you're logged in, you can just read this whole table. Or what we can do is we can take a table and then we can make a view on it. So this is a client writable view. So it's a version of the table that the client can write, but only the rows where the owner column matches this user, so the currently logged in user. And what that means is that the client gets something that acts like a table, right? This is calling the add row function on records, but it's restricted to, it can search, it can update, it can delete, but only rows. It's all enforced that owner is this user. So again, we can delegate a lot of this CRUD operations into the client code, so you only have to write it once rather than piping each of these operations all the way from the front end to the back end. So yeah, that's how we bring the objects, we keep the same objects all the way through and make that a useful concept. Finally, I want to finish up by talking about autocompletion, because you'll notice right the way through that demo that all the code I was writing was being auto-completed for me. And autocomplete is really great. It gives you discoverability. It lets you work out what your APIs are without having to flip to the documentation for each one. What your methods are, what your attributes, what the classes available are. It gives you speed, right? Because you can type a few characters and just hit the tab key. It gives you confidence that what you're doing is right. Apart from just, the fact that you've spelt that long attribute or method name correctly, there are also whole classes of bugs that you can fix without even hitting the run button, because the autocompleter is confirming to you that this is in fact of the type you expect. And it just feels good to use. Again, everybody here who uses PyCharm already knows how great this is. Those of you who are diehard Emacs or Vim users, all is not lost. You can use Jedi as a plugin for both of those, in fact. And if you don't use autocomplete in your daily driver editor, I would implore you, just do me a favor, install it, try it for a week. It will change your life. Unfortunately for us, these off-the-shelf solutions were not suitable. This is, for starters, because Anvil's full stack, right? It has to know about your database. It knows about your server code. It knows about, it knows about which components are in your drag and drop UI and autocompletes those. But more importantly, Jedi is, it's expecting files and packages on a file system, and we're editing in the web browser. And when you hit the tab key, there's just not enough time to go to the server, parse a bunch of code, find the completions and send them back. Just too slow. So we had to write our own auto-completion system in JavaScript. So yes, here I am at a Python meetup talking about my JavaScript project. Thankfully, behind a screen, I'm immune from the rotten fruit. So conveniently, for this particular project, we had a Python to JavaScript compiler knocking around. And as we've discussed previously, this contains the front end. So what we do when you hit the tab key is we actually take your module and then use the sculpt parser to turn that into an abstract syntax tree. And once we've replaced the cursor with a randomly named symbol and then just parsed it. And that means we can walk the abstract syntax tree and just keep a running tally of all the variables that are in scope at any given point. And when we hit that magic cursor symbol, we can just suggest all the things that are in scope. And obviously this generalizes to things like attributes on objects, the items are in something accessible by dictionaries, what you get when you iterate something, what happens if, what you get if you call something as a function, what its parameters are, what its return value is. Speaking of functions, as well as completing functions, like completing their arguments and their return values, we also want to go the other way, right? We want to complete the arguments of functions. So we want to do this from server to client as well. So here we are, we're on the client. I'm calling a say hello function, and I'm passing an object in. And really, when I'm editing that server function, I want to be able to autocomplete that object. And the way we do this is that when we're parsing the client code for autocomplete, as well as storing, when we do this, we store the top level scope, because that's what you get if you import that module. So we store it for future use in other modules. But we also record all the outbound calls from that module. So here we're going to record that we've called the say hello function, and we're going to record the type of the arguments. Then when we are parsing that server function, that server module for autocomplete, we realize we're compiling the, we're parsing the say hello function, at which point we can go and look at, oh, what are all the calls to this function and what are the argument types supplied by that. And then we can just drop that type of information into the local scope where it autocompletes as normal. So we really can store and autocomplete a lot of information about these types, which leads to a slightly philosophical conversation about what exactly a type is in Python. I mean, you could be very literal and say that the type of a Python object is the class it's an instance of, but actually Python's more dynamic than that. You know, individual object instances can have extra attributes just stuck onto them, or you know, we're talking you know, dictionaries. We complete items in dictionaries, so there's a good argument that these two variables are in fact of different types. And so what we do is we duck type our autocompleter completely. We pay relatively little attention to the formal, to the class an object is an instance of. As far as we're concerned, these two variables are of different types. They share a bunch of methods, sure, but they have different types with different item mappings. There's a bunch more I could talk about how Anvil works under the hood. I have an hour-and-a-half version of this talk, and I had to cut it ruthlessly to hit 45 minutes. But I want to close out by talking about a couple of things from the design philosophy that explain why we built Anvil the way it is and the things we're trying to do with it. Something we believe at a very deep level is that code is good. You're telling a computer what to do, right? Code is the best way to do it. Periodically, there's there come along things or ideas that claim you can do otherwise, that you can do, you know, that you can build an application without code just by drawing a flowchart. This is a tantalizing but ultimately false promise. You're telling a computer what to do. Sooner or later, your instructions are going to get to the level of complexity where you are shaking your monitor and saying, just let me write the darn for loop. So what we do is we say, actually, we've get you from where you are to writing the darn for loop as quickly as possible. Get you to the code. If you remember, even in the UI designer, when I was displaying that table of the previous visitors and I wanted to format the dates, you know, I wasn't dragging, you know, dragging wiggly lines from a database to a, you know, to a label. No, I was writing a Python expression right there in the drag and drop designer, which meant that I could use the Python functions that are already there and already plenty powerful for what we need to format that date. Something else we really care about is being accessible. And this is the big goal of Anvil here, is from the tool itself and for web development in general, to be simple enough for novices. There is absolutely no good reason why somebody who has learned their first programming language in Code Academy or has been doing a coding club or has attended a Raspberry Pi session shouldn't be able to build a web app, right? They should. And so we've tried to keep Anvil sufficiently simple that if you understand what the Python is doing, you're good and you can use this. But at the same time, we want to be powerful enough for seasoned professionals. And frankly, we are. There's, again, a lot of the stuff that I didn't get to show you in this talk, but we have, you know, full Git-backed version control that can integrate with CI/CD systems. We have escape hatches everywhere for, you know, running. You can interact with code outside, running outside Anvil. That's a really neat thing. I hope I get to demo that to you at some point. You know, there's if you want to go and wrangle the HTML and CSS and JavaScript, you can, and then there's ways of wrapping that back up as Python components that other people on your team can use without needing to know JavaScript. We really do think that these two goals are not incompatible, right? I mean, we can be simple enough for novices, powerful enough for seasoned pros. I mean, Python is both of these things, right? It's the language that your 7-year-old will learn at a Raspberry Jam, and it's the language that was used by DeepMind the first time an artificial machine ever beat a human at Go, right? It is possible to hit both of these goals, and it's only the state of modern web development that makes us think it's not possible. And so on that note of optimism, I want to say thank you very much. Thank you very much to IndyPy for having me, and a special good luck to everybody here who is pitching for Startup Row. Anvil was on Startup Row in PyCon 2017, and it was really the event that lit the fire under the company. So I wish that outcome for all of you. Very best of luck, and thank you very much.